Okay, so we are starting with chapter 8, and chapter 8 is going to be very quick. It's only 3 sections long, okay? But this first section is going to be kind of different than anything that you guys have seen before, okay? And there's a lot of formulas, okay? So here's what I suggest before you start, is I would make a note card or a piece of paper that has all of the formulas from chapter 8, okay? So that you can have just like kind of a quick reference whenever you're doing your homeworks and your assessments, etc. Okay. So we're going to start with this first idea, which is called the geometric mean, and the definition is going to be very different. All right. So it's starting off with, it says R, S, and T are positive numbers with, and I need to fill something in here. Okay. So it says R, S, and T are positive numbers with R over S is equal to S over T. So the way that this connects, before I finish this definition, is I just made a proportion. All right, so this is connected, all right, to what we covered last chapter with similar triangles, all right, where we are setting up proportional segments. Okay, so let's start from the beginning. So it says R, S, and T are positive numbers with R over S equals S over T. Then S is the geometric mean between R and T. So here's what I want you to look at. Do you see how with the S, all right, there's one on the bottom, all right? Then if you look at the other, all right, it's on the top. So they're going to be diagonal from one another, and these are going to be the same things, all right? So the two S's or the two X's or whatever we're using to represent S, all right, is going to be the same thing where you're going to have one on the top and one on the bottom. They're diagonal from one another, okay? So let's kind of just give you an example. So if you look at A, it says 12 is the geometric mean between, all right? So look here, okay? Those are diagonal from one another, okay? So it says 12 is the geometric mean between 4 and 36, because if you reduce those fractions, all right, 4 goes into 12 3 times, so that's 1/3, all right? 12 goes into 36 3 times, so that's 1/3. So those two ratios are the same, all right? What we're just looking for is that those 12s are diagonal from one another, okay? So let's try this next one. So it says, what is the geometric mean between 12 and 108? All right, well, here's the thing, guys. All right, if we don't know what something is, all right, we're going to place an X underneath that. But because, all right, they have to be the same thing, we're going to put an X on the top as well, okay? So let's just solve this like a proportion. If I cross multiplied, all right, I would get X squared is equal to, and then I'm going to multiply 12 times 108, which gives me 1,296. And then if I square root that, just a second, all right, I'm opening up my calculator. So then if I square root 1,296, I get 36. So 36 is the geometric mean between 12 and 108, okay? All right, so let's try example 2. So now example 2 says find the geometric mean between 6 and 10. All right, so all we're going to do now is we're going to do 6 over what, all right, because X is going to represent our geometric mean, equals X over 10, okay? Now we're going to cross multiply, and we're going to get X squared is equal to 60. Square root, X is equal to the square root of 60. Okay, now we have to reduce our square roots, and I know we went over this in class. Okay, I'm going to quickly go over how I do it. This is how I teach it in algebra, okay, where I'm going to break things down into factor trees. So I'm going to have the square root of 60 breaks down into, and it can be any two numbers, all right? So let's do 6 times 10. 6 breaks down into 3 times 2. 10 breaks down into 2 times 5. So what you're looking for are doubles, all right? Doubles of the same number. So if you see here, I have a set of 2's. So what the process is that I use to simplify radicals is you box the 2 that are the same in, but then you bring 1 out, all right? So that's the process. You box them in, you bring 1 out, okay? Now, 3 times 5, they don't have a pair, so you bring those back underneath the radical and you multiply them together. All right, so this final answer is 2 times the square root of 15. Okay? All right, let's try example 3. So it says the ratio of gear A to gear B is equal to the ratio of gear B to gear C. All right, find the geometric mean between gear A and gear C if gear A is 9 and gear C is 25. So we're essentially just finding the geometric mean between 9 and 25. Okay, so what I'm going to do is I'm going to do 9 over x equals x over 25. Okay, cross multiply, so I'm going to do x squared is equal to 9 times 25, which is 225. Square root that, and you get x is equal to 15. Okay? All right, I'm going to stop there. All right, we're not going to do example 4 because we're just going to move on to a new topic.